All right, let me show you guys how to find the components of a force in a plane as in 2 dimension. So look at something. A plane is just maybe something that is in 2 dimension or go to 2 dimension, like this. This part is 1 dimension, this other part is the other second. This is called X, this is called Y. The other one is called Y. So one is called Y. The other one is called Y. So you take care of that. So this X and the Y have opposite sign. This downside of Y is negative, while the upper side of Y is positive. So this one is actually, let me rewrite it again. This one is actually positive Y, while this side is negative Y. Take note of that. The same thing with X. Same thing with X. Same thing with X. This side is positive X. Positive X, while this other side is negative X. So any force going towards this any force going to the left hand side will be negative in S side. That is in the something like a S component. We call them component. Component means the amount of force going towards a particular direction. So S component now moving to the left is negative, to the right is positive. Y component to the downside is negative, to the upper side will be positive. That's the first thing you have to note. Very, very important. So a force can be in this form. A force can be this form. We can have a force in this place. We can also have a force in this place. We can also have a force in this place. We can also have a force in this place. And you must ensure that this for this particular concept you want to do now, you must ensure that this force we are talking about is making an you can see the direction of the force is the arrowhead. It must be leaving the starting point. It must be leaving the starting point, and it must be making an angle to the horizontal for this concept to work. The angle should be with the horizontal. Let's say theta to the horizontal, theta to the horizontal, theta. It must be, the angle must be to the horizontal for this concept to work. Remember that first one we did in that class, we did the frictional force. The angle was to the vertical, but this particular for this concept I want to use now to work, the angle must be to the horizontal. If the angle is to the vertical, reverse will be the case. I also explained that to you. So let's look at them one after the other so that you check how to get the F, S, and Y components. Say F, that is the force, the force. Remember, we are doing how to get component of a force. This is the force. So let's look at it one after the other now. So look at the first one. The first one. Call the F theta. Remember this plus this. Remember this side is plus X, and this other side is minus. I'm not. Can we just put them? This side is plus X, minus X, plus Y, minus Y. So if I ask you now, what is the S component of this force? What is the S component? What is the S component? What is the S component of this force here? You just tell me. The force to the S direction now will be equal to, look how to do it. You will take the force as far as it's making an angle of theta to the horizontal. That is the major thing. You will take the force, then check where the force is going. Also check where the force is going. If the force is going to the right hand side, the left hand is going to the right hand side, that means it will be positive. The force will be positive. So even though you don't add the positive sign, there's no problem. It's still the same thing. Then you take the force, use it to multiply cosine of the angle between the force and the x-axis, which is theta. That will be the S component of that force. While the Y component will be the force in the y direction will be equal to the same thing. Check if is it the upper side or in the downside. It's in the upper side, so it's positive for y. So it's still positive. You pick the force. You use to multiply sine, not cosine in this case now. Sine of the angle between this force and this horizontal, which is theta. The same between the force, the same angle here is the same angle here. The only thing is that for f, for y-axis, you take sine. For x-axis, you take cos. Remember the first one we did for y-axis, the one we were doing in frictional force. For y-axis, we took cos. For x-axis, we took sine. It was because the angle was to the vertical. If the angle is here, maybe the angle is to the vertical, reverse will be the case. This one will be x, then this other one will become y. And that's why I'm telling you, make sure the angle is to the x-axis so that this concept I'm teaching you now will work out. So taking note of that is very, very important. So this for this first case. Let's quickly run through the second case so that you see it. So this for the second case, we have something like this. Second case, we have something like this. Let's say there is the force. And if this angle of theta, angle of theta to the horizontal. So the s component here now, in the s direction will just be, check, this one is going to the left hand side, and in the left hand side s is negative. That will be negative f. The same thing, cos of the angle there between the force and the s axis. The y component will be, is going to the upper side. In the upper side, check, is in the upper side. In the upper side, y is positive. Positive f sine. You now take sine now of the same angle here. That is all. And let's look at the next one. The next stuff. Let's say the force is now here, theta. The angle must be between the force and the horizontal. Horizontal means this line lying down. That's the horizontal. So the f component of this particular one now, I'm looking at this one now. The f component of this particular force, so let me just rule it so that you know that part is gone. Let me just rule it. The s component will be equal to, let's check, it's still the left hand side. Check, it's still the left hand side. It's in this left hand side. It's still be negative f cos of that angle. The y component will be, check, this one is in the downside now. This force is the downside. Check, it's in the downside. So y will be negative y. We have negative f. Y will still be negative sine of that angle theta. That is all. So let's look at the last one, which is like this. This last one, which is actually like this. F. Angle CBD. Ensure the angle is not with the vertical. If the angle is with the vertical, you will remove 90. You will remove it from 90 to move it to the horizontal. So the f component of this now, the s component will be, check, this one now is in this, is in the right hand side. Check, it's the right hand side. It's particular force. So s will be positive f cos theta. This cos theta is actually gotten from that Pythagoras theory, and the SOHCAHTOA we do use, which is opposite over adjacent, adjacent over opposite over hypotenuse, adjacent over hypotenuse, and so on. But I don't want to be going to that place. It will be too something like a bulky. The y component will be check is the downside. Check, the force is the downside. So y will be negative y cos theta. So these are the 4 cases you can ever see as far as two dimension is concerned. So let's look at a question now. Let's look at a typical question now so that you will understand this better. Now let's say we want to check the components of this force here. Let's say you have a question like this. You have a question of this nature. Let's say here is 10 newtons. And here is 30 degrees. And they say find the components of this force. This one is horizontal. Not my drawing. This one is 10 newton. And this one is 30 degrees. So you find the component of this force. That's just it. The component of this force in the x, and you can see the x and y as just say the component of the x will be the force cos theta, which is 10 cos 30. So what is 10 cos 30? 10 cos 30 is going to give us a very lovely answer. Cos 30. So that is 5√2. That's 5√3 newtons. Or in decimal, you have 8.66. In decimal you have 8.66 newtons. Then the y component, let me just do this y component here. The y component will be the force 10 sine 30. Sine 30 now. So that'll give us, what is 10 sine 30? Sine 30. That'll give us 5 newtons. So please take note of that. It's very, very, very important. So this, the y component of that question now, the y component is 5 newtons. The s component, is what? 5 newtons. And the s component is 5√3 newtons, or 8.66 newtons. So that's how we can get the answer to that particular question. So let me look at another question so that you see it. Let's look at this other question. Let's see question 2. Let's go to 2. Let's see, you have something like this. Let's see, have something like this. Let's say this is 60 degree. And this is, let's see, this is 5 newtons. Let's find the components of these 5 newtons in the s and y direction. We also want to say, okay, the f's component will be, check, this one is going to the left hand side, check. If you complete this drawing now, this one is the left hand side. So the s components will be negative. So we're going to have negative of the 5 cos of that angle 60. So if you do that, you're going to have an answer. What is minus 5 cos 60? Minus 5 cos 60. That'll give us minus 2.5. Minus 2.5 newtons. Then for the y component now, the y component will be, just check. If you check now, this is the upper side. Y is positive. That's 5. Then you now take sine for y component. 60. Sine 60. Sorry about that. 60. That will give us, what is 5 sine 60? 5 sine 60 will give us something very, very important. 5 sine 60. 5 sine 60. That is 4.33. 4.33 or 5/2√3 newtons. Yeah, newtons. So that's how we roll. So let's look at, let's say we have a question of this nature now. Let's say we have a question, particular question of this nature. How are we going to find the components of the force? How are we going to find the components of the force? Now let's look at, they can also ask you to look for the resultant. Resultant will be equal to, they are asked to look for resultant. Resultant will be equal to the square root of what you got in the s, you square it, plus what you get in the y, you also square it. That is all. Let me look at another question so that you see it. Let me look at something that will have let's say a force is going to this side, and that force is going to this side. This one is 30 degree. This one is what's it called? 50 degree. So this one is 12 newtons. This other one is 14 newtons. So let's look at this now to see what we are going to have. So for the x, I will not waste time. For the x will just be, remember, in the left s is negative, the right s is positive. And another thing, for s, you take the force times cos of the angle between the force and the horizontal. Check, the angle is between the force and this horizontal now. So you're going to have this 12 is going to the right hand side. This one is going to the right hand side. So we're going to have 12 cos 30. Check this other 14 to the right, left hand side. Minus 14 cos 50. So that will give us a very good answer. So what are we going to have there? We have 12 cos 30 minus 14 cos 50. So we are having 1.4 approximately, or 1.393, literally 1.4 cos space newtons. That is all. Then let's look at for the y component now. Look at for the y component. For the y component to see what we are going to have. That is for the s component. And for the y component now, let's see what we are. So f to the y component now will be equal to, just check both of, if you will check very well, you discover that both of the forces are going to the upper side. That's just 12 cos 30. Remember, for y component we use sine here, not cos. So we have to change that to sine. So I just did that so that you will be able to follow. You have 12 for y component now. We have 12. We use sine, but the angle is still the same thing. 30. Then plus. Remember, both of them are going to the upper side. So both of them will be positive. 14 sine 50. So that gives us, what is 12 cos 30? We have 12 sine 30 plus 14 sine 40 sine 50. We have 16.72. So let's just call it 16.7 newtons. So the s component, for s component we had 1.4 newtons. For y component we have 16.7 newtons. Now what about if you are asked to look for resultant? Remember, for s component we have 1.4 newtons. For y component we had 16.7 newtons. Now that's why if you ask to look for resultant, the resultant will be, square root of the s component, which is 1.4, then you square it, plus the y component, which is 16.7, you also square it. Square root will cover everything though. So if you find the square root of, this is square root of 1.4 squared plus 16.7 squared plus 3.7 squared, that will give us 1.4 squared plus 3.7 squared is 16.76. Now 16.76 newton, approximately 16.8 newtons. So that's how to calculate resultants. So I just quickly did that. So I've showed you how to calculate component of a force and resultant of a force. So please ensure you are able to do things of this nature if they are if you see them anywhere in the, maybe in the exam. Let's also look at this. Let's look at this question. Let's look at this. Let's say we have something like this. Let's say we have a diagram like this. Then we have 4 newtons going to this side. We have 9 newtons go downward. 9 newtons go to this side. We have 10 newtons go to this side. How do you resolve something like this? You have 10 newtons go to this side. How do you resolve? Let's say we have x, arrow, q, p. How do you resolve something like this? So look how to do it. If you check now, this is horizontal line. This is also horizontal line. So in terms of forces, they are acting along the same place. Something like they are both in the same what's it called, line of action. This one is horizontal, this one is horizontal. But check, this one is moving to this side, while this other one is moving to this side. So anyone going anyone going to the left will be positive, negative. Anyone go to the right will be positive. But anything that is moving in the horizontal direction, there will not be y component for that force. Take note of that. Any force moving along the horizontal component, something that is moving along the horizontal, anything moving along horizontal, there is no y component for that force. Any force moving along the vertical, there is no s component for that force. Also take note of that. So look how to just do this one now. It's a very simple thing. Look how to do it. You just come and say, okay, at it. S component will be equal to, you will check those moving in the horizontal or in the s axis, which is this and this. This one is going to the right. Check, it's going to the right. It's going to the right. That is plus 10. Don't multiply with any angle because it's already moving along the s axis. Don't forget about, there's no angle there. It's along the s axis. This one is also along s axis. Check, along horizontal, but it's moving backward, going backward to the left. That is minus. That will be minus 4. That will be minus 4. That will be minus 4. 10 minus 4 is equal to what? 6 newtons. So this is the s component. Now for the y component, f of y will be, we check which of them is going towards the vertical side. Check, this one is going to the vertical side. There's nothing here. As if there was another one here, now moving this side, we'll add, but there's nothing there. So you forget about that. But if you check, this one is going downward. Check, it's going downward. So that will be minus. That one is very important. 9 newtons. That is the y component. There's no other force going to the vertical direction there. So in this case now, our s component is equals to 6 newtons, while our y component is equals to minus 9 newtons. That's how to do this stuff. Please take note of that. It's very, 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 very important. Then, if I now ask what is the resultant, the resultant will be equal to the square root of c squared plus, don't add this sign when you're looking for resultant. No, you don't do that. Just take plus the value, which is the magnitude only, and you square it. Because even though you take the sign and square it, the sign will tend to plus again. So there's no need of taking the sign so that you don't make a mistake. So when you are calculating for resultant, don't use signs, use plus throughout, and take note of that. It's very, very important. So if you do this very well, 9 squared, if you do very well, let's say the square root of c squared plus 9 squared, it will be equal to 10.82 newtons. That will be the resultant. This is the s component, this is the y component, this is the resultant. So let me do one more. To let me just do one more so that this video will not be too long. Or let me just give you guys 2 to do, then I'll just put the answer there. The first one is like this. Here's 60 degree, here's 10 newtons. So you can do this. F of x will be 10 cos 60. Check if you can do that. F of y will be 10 sin 60. Check if you can also do that. Then you can do that. So check that too. The other one is something like this. The other one is something like this. The angle is 30 degree. And here is 12 newtons. Check you can do this with s component. F of x will be minus 12 cos 30. So will be equal to what? Then the y component will be 12 sin 30. So you can also do that. Just solve them and get the answer out. Then let's say we have something like this. So we have 20 degree, 2 newtons. F of x will be 2 cos 20. F of y will be minus 2 sin 20. So that f of s now, if you do it, you're going to have, you see, 2 cos 20 is 1.9, approximately 1.9 18th. Then f of y is minus 2 sine 20. 2 sine 20, that's 0.7, approximately 0.7. So check if you can do this. Check if you can do this. Very, very important. So thank you. God bless you all.